Good morning, YouTube. Happy Tax Day. It's April 15th, 2019. I've been doing a bunch of videos, popping out a bunch of videos the past few months, trying to concentrate on the math part of the SHSAT, and indirectly that means going over grade 7 and grade 8 math, as well as some other things. So I'm just going to keep banging that stuff out. In the meantime, okay, wait. Let me load this down. Alright, so I'm going live, double checking that. My name is Greg. I'm at Greg's Tutoring and NYC at gmail.com. I'll say that again. My name is Greg. I'm from Greg's Tutoring NYC at gmail.com. I mainly specialize in tutoring specialized tests, even though I do homework help and the New York State test and small projects here and there, help kids with writing, all different aspects. But my main forte and the part I really enjoy the most is the specialized test. So it's the SHSAT, the New York City Specialized High School Test, the Hunter College High School Test, Baccalaureate. There's even some middle schools I do, Anderson, MS54, you name it. A lot of the tests I do, the SSAT, the ISEE, which is important for some of the private middle schools and elementary schools and even high schools. So with that in mind, let me just jump into here. I took an old state test. That's what we're going to go over right now. We're going to go through the book 1. So I'm going to try to bang through it as fast as possible. Some of this is review from some other videos I just did recently. So I suggest looking at those. This probably is going to run 45 minutes. I think it's not the most in-depth state test there ever was. But I want you to notice it runs the gamut. So here's the thing. On every state test, there's 30, 40, 50 questions per book. Depends on the day. It used to be 3 books. Now it's 2 books, which means it's 2 days. What they have to do is, out of all the topics you know, let's say grade 7 math, there might be 100 to 200 topics. I'm talking subtopics. So we might talk about algebra, but within algebra there's a whole bunch of different topics underneath that. So we need to keep things in context. So what they're going to do is, out of that, say 150 topics, they might give you, as I said, there might be 50 questions on this book. So out of the 50 questions, it might cover hundreds of the subtopics. Because sometimes there's 2-part questions, and sometimes a question needs you to do another part, and yada, 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 and so on and so on. So what happens, though, is that if you go across years, if this is going to do 100, and I'm telling you there's 150 or 200, what happens to the other 50 or 100 topics? They're going to be on the next test. So what happens is there's kind of a common group of questions that they're going to ask every year, maybe 75 topics, which means half are missing. So if you cover a couple of years of state tests, you'll end up covering them all. The other issue is that in some cases you're only going to get one shot at some of these questions. And there's some questions that your teacher doesn't really view. It may have actually been part of 6th grade math. Because remember, 7th grade math is part of 6, 5, 4, 3, 2, 1 grade math. And it's just stuff. So we're talking about memorizing everything, making sure you understand it, because memorizing math is just not about memorization. So you might know formulas, but how do you use them? Can we put them in context? Things like that. So those are just as important too. So we have all this myriad of stuff going on at once. In some cases, you only get one shot at answering that kind of question. And if you blow it, the next question is about another subtopic. So you really need to be on your toes and keeping up. This is not only so for the state test, but for also the specialized high school tests and things like that. That said, a lot of kids are doing poorly on the New York State tests. Most kids do not get a 4 out of the 1 through 4 range. Most kids do not even get a 3. So the average kid is getting maybe a 2.5 to a 3.5. So let's see if we can help that some here. And remember, the questions here are across the board. Some are really easy, some are more in the middle, some are more involved. So with all that in mind, let me just start jumping right in here. I'm going to put me to the side. Let me just check 1 second before we continue to make sure I am live. Yes, I seem to be. Okay, so give me 1 second to bring that browser. I'm going to do this through a browser. I modified it slightly So let's see what's happening. Okay. All right, my phone is showing the right thing. And what I'm going to do is see if this works. Testing 1, 2, 3. I have a thing on the side here. Let me just make sure that's coming up. Yes, it is. Okay. So the first question, we can just jump right into it. What measure is equivalent to 1.5 kilograms? And they're giving us a fact here. That's what the box is about. 1 kilogram equals 1,000 grams. And then they have A, B, C, D. There's a couple ways to solve this. Okay. You could set up as a ratio. 1 kilogram is to 1,000 grams. Okay. That's represented as a fraction. So we can say 1 kilogram divided by 1,000 grams. Okay. And we can write this, if we write it up and down instead of across, 1 kilogram is to 1,000 grams. And we're going to set that up as an equivalence. Equals, okay, and the question tells us it's 1.5 kilograms. Oops. Actually, let me see if this is coming on your screen. 1 second. Yes, it is so far. So I want to make sure things are not falling off. Give space for the question and also to show where the answer parts are. And this is what we're trying to solve. How many grams? Okay. All right. We could also set this up as a different kind of fraction, by the way. We went from kilograms to grams equals kilograms to grams. So we could also done it 1 kilogram is to 1.5 kilograms. As 1,000 grams is to, we're still looking for how many grams here too? G grams, right? We're looking for grams. That's what we're looking for at the end. If you look at all the answers, they're on grams. So let me bring up something here for 1 second. Oh, you know what? I can't do this with that. Okay. All right, well, we're going to do the cross product, also known as the butterfly technique. So what we're going to do is make an x with both of those two fractions. It doesn't matter which one we choose. So what we're going to do is take the upper left, the 1 kilogram, and multiply it by the g grams. And then we're going to take the lower right and multiply it by the upper left there. Let me bring up something for 1 second. So if we have the two fractions, if we have A over B equals, that's an equal sign, C over D, what we're going to do is multiply here and multiply there. So we're going to get A times B, whatever that happens to be, and make that equal to, sorry, that should have been a D. This is an uppercase D. Let me do this a little better here. A times D equals B times C. So that's what we're striving for in the two multiplications. So let me bring back my notepad thing. So we're going to get basically 1 times G equals 1,000 times 1.5. And if you multiply that and do the division, you're going to end up with C, which is 1,500. Okay? Okay, question number 2. Let me see if I can get this scrolling right. Let me clear this. Okay, at noon on Monday in Minneapolis, the temperature in degrees Fahrenheit was -4 degrees Fahrenheit. At noon on Tuesday, the temperature was 6 degrees higher. So higher is important here to note. What was the temperature? Okay. Oops. Okay, we started here. It went higher by 6 degrees. Okay. So this is just simple arithmetic you can do in your head. Formally, what we're going to have for this question is we're going to have minus 4 plus 6 degrees, and that's going to be equal to 2. Okay, so that one's more or less easy peasy. Okay, let me just make sure we're live still. Yep, looks okay. Okay, the prices of a plasma TV at electronics store are shown below. So here's the various prices. Okay. What is the range? So this is a technical word. This is a mathematical technical word. Okay, when you take things like the average, the mean, the median, the low value, the top value, all sort of stuff. So the range is the top number minus the low number. Okay, in this case, it's our maximum number. What we need to do is put these numbers in order. And if we do so, we can notice this is the highest one. Is that correct? Yes. And this is the lowest one. That's the highest one, and that's the lowest one. What we're going to do is subtract them. So let me see what we get. Hang on one second. We get 2285. I can't bring up a calculator here. 1116. And we get 1169. So the answer should be B. Okay. So again, these ones aren't too bad so far. And you might argue, oh, this isn't too tough. Well, let's see. Okay. Question number 4. Which expression is a binomial? Okay. This is one of those free questions. This hardly ever comes up. But it comes up, not necessarily this question itself, but the type of question. And this one's a frowny, because it doesn't come up that often. And this is one of those things where your teacher may or may not have mentioned it one day in passing. And some of you may even know what a polynomial is. It means many terms. So binomial means many terms. But again, this is a mathematical terminology aspect. Again, the second one, the other one was as well. And so what does it mean to have binomial? Bi normally means 2, like bicycle, 2 wheels. Biped, we're bipeds, we have 2 feet. Okay? So binomial means 2 terms. So from that aspect, it rules out D. Okay? And it turns out this here is a term, and this here is a term. So this really means you have to know what terms are, because even the bi doesn't help you. This is squared, so it has kind of a 2 aspect to it. And 3w, even though this is a coefficient in the symbol, you could argue, isn't that 2 things as well? So you can't even sort of guess with this, because unless you know exactly what a nomial is, you're screwed. Okay? But it means 2 terms. So let me clear some of this nonsense I wrote here. This is 2 terms. The 1 is a constant, and the 3w is a w term. There's 3 of them. Okay? So the answer here would be C. So this is one of those ones, either you know it or you don't know it. In enough context, you can figure out what binomial means. And hopefully you guessed on C, if you weren't exactly sure. Because you may have known this one, even though I said they both had this duality to them. This had the 2, and this had the multiplication, the 3 times the w. Normally your teacher would have never called this. You would just call this p squared, or this deals with exponents. And this deals with more multiplication. There's 3 w's, or w plus w plus w. So both of these kind of, even though this 2-ness to them, there's 2 things going on, the squaring and the 3 times the w, they're kind of the weaker ones, but this is a tough one. And this is one of the ones you should maybe just answer and move on. Hopefully you know the answer. But and this is one of those terms, binomial, it's almost never talked about in class. Okay? So let's move on. Okay, 5. A box contains 6 red pens and 4 blue pens. Corey randomly picks a pen from the box and keeps it. This is significant that he keeps it. Todd then randomly picks a pen for the box. What is the probability that both will pick a red pen? Okay? So normally the probability of picking a red pen, since there's 6 plus 4 pens, so there's 10 pens, is 1 out of 10. It's 1/10. Right? Let me see if you guys have this blocking your view. No, you're still good there. All right. So if Corey picks a pen, his chance of picking a red is 6 out of 10. There's 6 out of 10. So then you might say, what's Todd's chance? Isn't it also 6 out of 10? No. Because a pen is already removed. Todd kept it. Todd keeps the pen. I mean, sorry, Corey keeps the pen. So Todd's chance, because there's now a pen missing, and it's a red one. So now we went from 6 red pens and 4 blue pens to 5 red pens and 4 blue pens. So now we have only 9 pens. So a chance of getting 1 is 1/9. So if there's now 5 red pens, then Todd's chance of a red pen is 5 out of 9. Okay? And on a problem like this, we multiply. So we're going to have 6/10 times 5/9. And we're going to get 30/90ths, which is going to be equal to 1/3, which turns out to be A. Okay? So this kind of problem has 2 aspects to it. One is you take the chance that each person had and you multiply them out, because that's just the way it goes. Okay. The other is if somebody takes a pen and puts it back, or takes it and puts it and keeps it. It's 2 different examples. If Todd had put it back, it would have been 6/10 times 6/10. But since he kept it, there's 1 less pen, so you have to figure it out from there. Okay. Okay, number 6. Whoop. Okay, simplify the expression. So we have -4 minus a minus x. So a minus is a positive. So basically that converts to -4 plus x. Sorry, I wrote this wrong. That's -4x minus a minus x. So we get -4x plus x, or -3x. So 6 will be C. Okay? That's just once we do the minus thing. So this comes up often where with multiplication and with division, you have a plus plus, a plus plus a minus plus a plus, and a minus plus a minus. We have the same thing with multiplication. A plus times a plus times a minus times a plus, and a minus times a minus. You need to know those rules. Okay, and they're actually not too bad to remember. And I think it's pouring out. By the way, happy tax day, everybody. I should be doing my taxes instead of doing this. Okay, 7 is similar. What is the value of the expression? So we have 2 plus 3 squared. Okay, I can't do squares, so that I'm doing a shift 6, which is called a caret. I'm doing 3 caret 2, which means 3 to the second, plus, and we have the absolute value of -4. Okay, so we just do our substitutions. 2 plus 3 squared plus 4. The absolute value minus 4 is 4, and we just chuck it in there. So we're going to have 2 plus 3 squared is 9 plus 4. Okay, and we get 11, so we get 25. What did I do? We get 15, right? No, we don't get 15. 9, 10, 11. Yes, we do. I wrote that wrong. By the way, I wrote in my comments, I have slight dyslexia, and I can't see sometimes things totally obvious the first time through. I train myself to try to catch them. Okay, so we get 15. 7 is C then. All right. So let's move up to the next one. A regular pyramid is shown below. Okay. So in this one, what shape could be the base of the thing? So you can argue what is the base, but the base really is this here. So what shape is that? That's clearly a square. No-brainer. No-brainer. Let me just check that we're still live. Yes, we are. All right. Let me go back to the browser menu here. And by the way, you need to know your shapes. So you need to know what a pentagon is. A triangle, obviously most people do, and a trapezoid. These guys, you need to know what they are. So the other faces of this rectangular pyramid here are triangles. There's actually other kinds of pyramids. The standard pyramid, like the one in Egypt, is normally of this shape. There's actually different kinds of pyramids. So you should get to know those too. They can come up. Okay, Gary and Thomas are playing a game with number cards. At the end of the game, Thomas still has 5 cards. If the value of each card is minus 50 points, how many points does Thomas have? Okay, so this really deals with negative numbers again. 5 times minus 50. And that's just minus 250. We have a positive times a negative. The 5 is positive. We have minus 50. And we can look at it this way. If we go one at a time, if he had 1 card, he's minus 50. If he has 2 cards, he's minus 100. Then minus 150, minus 200, minus 250. All right, so this is a no-brainer. We can also flip it, right? A times B is the same as B times A. So this could also be minus 50 times 5. Okay, whether we put the parenthesis in or not. Okay, and this one, just like the one up here, this here, we're just following PEMDAS. Remember the order of operations and their associative capabilities? So parenthesis gets done first, and then we work out each thing from each other part. Okay? So 9 wasn't too bad. 10. Find the value of A in the equation below. Okay, so now we start getting deeper. We're into algebra here. So we have 3A plus 2 equals A minus 6. So that 3A means A times 3. Okay? You have different workbooks and different fonts that your teacher gives you and things like that. So before we start, 3A means 3 times A. Okay? Just there's different ways to write that. We can write 3XA, right? In some that's the actual asterisk, which is the shift 8A. Okay, and some, instead of, I'm going to make a period here because I have no way I'm not sure how to do the dot. It's the little raised dot times A, or it can just be 3A. Okay, they all mean this is A plus A plus A. There's 3 A's. Okay, so now we get into the algebra part. So there's a kind of a long explanation here. So I'm taking the perspective that this is tutoring at the moment, and that you know how to do this procedure. If not, you need to do some serious review. But there's a couple of steps to it, which involves looking to see what's on the left side of the equal sign and the right side of the equal sign. And this can apply to inequalities too, so it's not always just the equal sign. We're going to combine like terms I mentioned about terms earlier when we're talking about the binomial. I think it was question number 2. And what we need to do is then get the symbol by itself. In this case, the symbol is A. So there's a few ways to approach this. I like to approach it where I avoid negative numbers as much as possible, especially involving the symbol. Okay, so since there's an A term on the left side and a constant's a number, so like the 2, and an A term on the right-hand side of the equal sign and a constant, I'm gonna just try to get one or the other on one side. So I see if I bring the 3A to the other side, I'm going to end up doing a subtraction. So what I'm going to do is I'm going to subtract A from both sides. So that you end up with a 2A plus 2 equals minus 6. And I'm going to come along. So my goal is twofold. I'm going to combine like terms, and I'm also going to get the thing with the symbol, which is in this case the 2A. Okay, I'm going to try to get that by itself. So I'm going to subtract 2 from both sides. So I get 2A equals minus 8. Okay, so now that I've combined all the like terms, now I'm only left with an A term and a constant on the other side. So now my goal is to get A by itself. So one way to do that is divide this side by, so if you notice what we're doing, if we go up here, what we did to one side of the equal sign, we did to the other. Same here, what we did to one side, we do to the other. So we're going to do it here. What we divide by 2 here, so we're going to come with the minus 8 and also divide by 2. So 2A divided by 2 is A, and then minus 8 divided by 2 is minus 4. Okay? So 10 will give D. Okay? What we want to do too is we can plug some of this back in to do the double checking. So if we go back to the original thing, 3A plus 2 equals A minus 6. So let's substitute it in. 3 times minus 4, and I'm going to parenthesize this because of the negative, plus 2 equals minus 4 minus 6. So what we can do is just do it. So we end up with minus 12 plus 2 equals minus 10. And then minus 12 plus 2 is minus 10. So minus 10 equals minus 10. So this step is important to do because you're double checking. A lot of people don't like to do the double checking to the very end of the test. I half agree to that when this state test used to be 3 hours. But now that you can go to the end of the day, I would say do your double checking right there up front. Because it used to be you may have run out of time, and by the time you did all the extra thing doing double checking, you may have ended up not answering questions. And on this kind of test, you should answer all questions. You don't get penalized for a wrong answer. So if you have a way to make an educated guess, or even in this case just a random guess, it's worth doing it. Of course, you should know how to do it, but I'm just saying you can bump up your score by making educated guesses. Okay? So you have the time to run this through and do the double checking live as you're doing some of these problems. By the way, you should also code your test paper, especially this part. The only thing the state sees is your bubble sheet, so you can write anything on this part of it. This is not the book with the show your work questions. That's a slightly different story because there you could be writing stuff that is inappropriate or not involved with the question at hand and so on. And the teacher's only supposed to look at certain places, and if you put another question in the other space, it gets complicated. But in this part, you can put anything down what you want. So I would start coding, putting codes next to your questions. I would even do it with the show your work ones, but if you're satisfied with 10, you can put a check there or something. Even after double checking, if you're still not sure, put a question mark and circle it or something. Work out a code. It doesn't really matter what your codes are as long as you're consistent. So that at the end of the test, if you go back to 10 and you see it says XYZ, and you're like, wait, what did XYZ mean? So when you're doing your prep and your practice, you should be just starting developing codes. You also, maybe going into a test, you should know your strengths and weaknesses. A lot of people don't, which I think is their demise. And this is important, where you should have prepped already and known what your strengths and weaknesses were. And already tried to work before on improving your strengths and improving your weaknesses. Test anxiety and other things are bad and hard enough. that you don't need to complicate it by going into a test unknown. So if you do enough practice tests, you should have an idea what your score is going to be. I'm not saying that there's no guarantees here, but you don't want to walk and get a surprise like you thought you were 100 and you got a 0 or something like that. So if you do enough tests, you're going to know if you're a 50 student. You're going to know if you're about a 75 student. And if a particular test is easier or harder one year, well, so be it. But at least you did some due diligence to try to figure out where your work is. Okay? So this is just some philosophy and some word of wisdom. Okay, let me check my phone to see if I'm still live there. Yes, I am. And I'm noticing part of this is falling off. So let me raise this up slightly. I apologize for that. It looks okay on my screen here. So let me just move this up slightly. Because I notice I've been talking and some of this is falling off. So what you may want to do at this point is pause the video and go back to some of the questions to try to follow through there. You can write down what I've written on the side here. It was showing my screen is coming up, but I just looked at the phone, it wasn't, so I just raised it. I guess there's some incompatibility in the screen size or something here, so I'll make a note of that. I think the problem may have only been with the last one because I got to the bottom of the text that it went to here. I can do this on the Macintosh, which is fine. Okay, let's go on to the next question. Let me go back here. Okay, question number 11. So if you're following some of my other videos, what I like to do is look at only the table first. I ignore all words, and I just try to understand what the table is about. What's important, though, I notice a lot of kids don't read this part here, and they jump right to this. It's almost like this is directions to them, and they just ignore this part. You can't do that. So no matter what order you do this in, I'm telling people to do this first. But some kids are going to skip up here anyway, and you can't. It's part of the problem. All right? So let's clear this for a second. So I'm just going to look at the table first, and after that I'm going to come back up to here. And then third finally go to the question. Okay? So what I like to do is look at what's going on with the axes, look at what's happening with the chart, and maybe testing out one or two things. So it says chicken wings, which is really devoid of meaning to me at the second. So I'm going to look at the y-axis, which is the one going up and down. It says number of wings. The bottom says type. So I'm saying barbecue, garlic, hot, plain, teriyaki, number of wings. So it looks like either somebody ate or they're selling or buying something. So for argument's sake, there were 8 garlic wings, either bought, sold, eaten, whatever the heck may be, whatever the question's about. I'm also noticing, and this is important too, this axis here, these are not going up by 1. It's 2, 4, 6, 8, so they're going up by 2s. So that might end up being significant. It's easy to look at this here. Well, let me bring that back. This here, and the difference between this here, and say it's 1. And it's a teriyaki minus the garlic. But it's 10 minus 8. Okay, so that's 2. So I don't look at the question yet. I don't know what the question is yet, so it might come up. So this is some of the things I'm going to test myself on, though. I'm going to say, for instance, what's the largest one? Okay, it turns out that plain is 18. What's the lowest one? It turns out that that's 8. So the difference between plain and garlic is 10. Okay, I can also do something like test myself and figure out the average here. But that's getting too busy because I don't know what the question is, and I don't want to do too much experimentation here. All right. So with that in mind, I'm going to go to the question now. So Mr. Wilt prepares some chicken wings for a picnic. The bar graph below shows the number of different chicken wings he prepares. Okay, so that's what we have. So let me raise this up. Try to get it all on the screen. Let me just see if it appears in the screen. Yes, it is. Okay. So based on the bar graph, which of these statements is true? Actually, let me raise this slightly because it looks like that bottom. Or let me do this. think if I click on that, that goes away. And then it comes back. Okay, wait. Let me shrink this for a second so we can get it all on one screen, and then I'll shrink it back up. Okay, Mr. Will prepares 2 more plain wings than hot wings. Well, plain is 18 and hot is 16. So again, that's not 1. That's 18 minus 16 is 2. So it seems to be A. So we're going to make a mental note so far. So a lot of people would just give up on the problem at this point and say, oh, Jay, move on. You know what? You want to double check. You want to make sure you didn't misread the question. You want to make sure you didn't misread this answer. Because if you get 2 answers, this is the kind of test where you're not supposed to get more than one answer. So Mr. Will prepares twice as many plain wings as hot wings. So he's got 18. No, that's not multiplication. So that's not true. Mr. Will prepares 2 more barbecue than garlic. So he's got 12 and 8. So that's 4. Again, there's 2 lines there, but it's actually, since each thing on the y-axis is by 2, then it's not just 2, it's times 2. So you get 4. So it's not C either. Mr. Will prepares twice as many barbecue. Okay, I don't even know where he's coming from here. So A wins. Okay? So this one is literally about interpreting a chart. Okay, let me bring this back up. Let me just make sure we're still going live. Okay. Yes, it seems like we are. Okay, Derek has 12 shirts in his closet. If 2 out of every 3 of these shirts are striped, how many striped shirts does Derek have in his closet? So, we have 12 shirts, 2/3 of them, of means multiplication. 2/3 of them so 12 is the same as 12 over 1. So basically what we then end up having is 24 over 3 and that's equal to 8. Let me double check that this is still on the screen because before it fell off. Okay, so we're good. We could have also done some canceling out, although this one was quite simple. Since the numerator has 12 and the denominator has 3, we could have done 3 into 3 is 1 and 3 into 12 is 4 and gotten 4 times 2 equals 8. They're all valid approaches. Again, in a show your work problem, either one or the other would work. Okay, so we get 12 should be B. Yes, okay. Okay, 13. Let me bring up the right window here. Okay, which of these is a unit of measure for the mass of a bag of apples? So kilograms, grams is a weight, so it seems to be A. Kilometers, meters is the length, so that's no good. Cubic inches is the length. Actually, that's actually a volume, so it's a capacity. In other words, you fill something up an XYZ container, like a container of milk, which should have cubic inches. There's 3 dimensions to that. And D deals with a unit of length, which is really an X times a Y. Square inches is dealing with area. So the one that deals with the weight is definitely A. Okay? Okay, 14. I'm just looking at this. By the way, there's patterns to a lot of these questions. You'll see some similar ones coming up. The point is less to memorize them, to just get familiar with them so that you're pacing yourself properly on tests like this, especially if we tie it back to this things like the SHSAT. Joan flipped a coin, so this is a probability and statistics one. Joan flipped a coin 100 times during a mathematics experiment. This is important. The coin landed on tails 36 times. Based on her results, which of these statements is true? So what we have here is there's the theoretical probability, and then there's the actual experiment happening, which is what happened. So one is the experimental probability, and there's the theoretical probability. Okay, so before I give the cat out of the bag, let's just go through them and you'll understand what I'm talking about. The coin landed on tails more than expected. Okay, that's what we're talking about here. What do they mean more than expected? That's kind of odd phrasing, but not if you realize it. If I have a coin and I flipped it 100 times, what's the theoretical probability that it's going to land on the heads or tails? It's 50-50. Unless the coin is not a fair coin, or if it's a weighted coin that you loaded it so it only lands on heads either all the time or most of the time, then you have an unfair coin. But if you take a random coin and flip it 100 times, you would expect it to land on heads 50 times and tails 50 times. At least theoretically. In this case, it didn't. It went 36 and 64. Okay? It did tails 36 and went on heads apparently 64 times then. So the experimental was 36-64. The actual should be 50-50, or 1/2. 50% of the time. In this case, it only went on tails 36% of the time. So with that in mind, let's revisit these statements. The coin landed on tails more than expected. No, we expected to land on tails 50 times. So it's not A. It landed less than we expected. The coin landed on heads less than we expected. No, we expected heads 50 times as well. And it went 64 times on heads. So it's not B. Okay, C says the coin landed on heads more than tails. Yeah, that's what happened. It went 64 times on heads and 36 on the tails. And just to be thorough and doing double checking, the coin landed on heads less than tails. No, the coin landed on heads more. So 14 will be C. Okay? Okay, 15. At this point in the semester, all of you should have had this taught to you. The math state test is in 2 or 3 weeks. And your teacher better have taught this. If not, it better had well be one of the last topics so that your teacher leaves a week, because you're going to have your spring break next week. And you really only have 2 weeks of school until the test of, if I'm doing the mental math in my head correctly here. This kind of thing involves 2 aspects of things. First of all, it's involving an inequality. So it's not an equal sign, it's an inequality, which means x is greater than 26. Is not saying x is 26. Although part of an inequality sometimes involves equality, because it could have said x is greater than or equal to 26. Okay? Alright? So normally on a number line, let me bring up my handy dandy thing here. Normally on a number line, if I said this was 0 and this is 1. So if I said x was 1, I would darken in a little thing here. Right? So it's darkened because it's saying it is there. Okay, and if you notice, it's not on 0 because it's not part of 0. It's not on -1 because x, I'm telling you, x is a 1. So we're using that same kind of logic when we come to all these examples over here. Okay? So let me go through them and show them what I'm talking about. So first of all, it says x is greater than 26. So what we do is we draw an array. For instance, the 2 things with the arrows, they're rays. Okay? So the number line is a ray normally. It's a line actually. But when we actually darken in the equality, we're going to make it as a ray. Okay? So if you notice, there's the number line, and then there's a darkened, a bold-faced line on top of it, which is showing the ray. So first of all, we want to capture which of these even covers the set of numbers it's talking about. So if x is greater than 26, if we just look at integers for now, it's 27, it's 28, it's 29, it's 30. It's not 25 and 24 and 23. So that rules out B and D, because they're going the other way. And A and C cover the higher numbers. So now we're left with 26 having a circled hole, not filled, filled in, and C having the whole filled in. Well, this is the example I just gave with X is 1. So if X is greater than 26, it's not going to be C, because 26 is not part of what X is. Okay, but A represents it, because A says it's 26 and above, but not 26. So 15 will be A. Okay? There's more involved ones of these. So, in fact, in some of the show your work ones, you actually have to compute the inequality and then graph it. And these can be tricky. So just at this level, this is kind of the basic knowledge you need to know about some of these. And it just builds on there from that point. Okay? Okay, 16. Helen is preparing candy bars for the children at a party. She has 2 flavors of lollipops, 4 types of candy bars, and 6 flavors of chewy candies. Oh yeah, I'm getting hungry. In fact, it's getting towards lunchtime. If each bag, she's doing a candy bag up, if each bag contains 1 piece of each kind of candy, what is the total number of possible candy combinations for the bags? So first of all, we're not going to get into arguments like is a lollipop a piece of candy, and so on. These are 3 different candies. 1 second, my phone is ringing. These are 3 different candies, and this is a traditional question that comes up. In fact, you probably saw it last year. You maybe even said it in the 5th grade. And it's going to come up again. It's going to come up during some of your high school regencies, and you're going to see it even on the SAT. This is a standard problem. It normally takes 1 of 2 forms, which is basically you have a pizza, you have different sizes of pizzas, and you have different toppings. How many combinations can you get? The other classic example is like dressing yourself. I have 3 hats, 3 shirts, and 3 pairs of pants. How many combinations can I get? And when it's written like this with no idiosyncrasies, no pathological cases, nothing out of the ordinary, there's X of this, Y in that, and Z of that, you just multiply the numbers out. Okay? You could write them out on the side and all the permutations if you want. This is doable, but really all you have to do is remember to just memorize, is multiply them. So you have 2 times 4 is 8, and 8 times 6 is 48. So in this case, if you actually wrote out the permutations on the side, you would be writing out 48 of them. Luckily, these numbers are distributed apart enough, because if it was the choice between 48, 47, 46, and 45, that would make the problem infinitely harder, because people who don't realize that it's multiplication, and they write them out and leave out one of the scenarios in the list of 48, you might accidentally leave out 2 or something. So then it becomes harder. So you need to know the math, not just the robotics of it. Okay? So the answer here would be D. Okay, 17. What is the area in square units of the shaded region on the coordinate plane below? Okay, so there's no key provided here. So we have each little box here is worth 1. We know it's worth 1 because we're going from 1 to 2 here. So our x-axis is by 1, the same on this side, and our y-axis has the same thing. It's going up 1, 2, 3, 4, 5, 6, and down 1, 2, 3, 4, 5, 6. Okay? So we have a 1 by 1. Each little box is 1 by 1, so it's 1 square unit. Okay? And we can confirm that because it says, what is the area in square units? So it wants us to shoot at that. It could have been 2 by 2, and we had at the end we may have it divided by 2 or something, or divide by 4 because it's square units, okay, of the shaded area. So there's a few ways to approach this. Let me, I'm going to expand this once or twice for a second. I'm going to expand it twice. Bring up this here. Okay, one way is to get, wait, it's not coming up. Give me a second. One way is to get the area of this whole box, and then subtract 2, and then subtract these boxes here. Okay. Another way is to get the area of this. So this is 2 by 4. Get the area of this. which is 6 by 2. And then add these ones. You could even do it another time, which is get the area of this, and then the area of that, and add them all up. Okay? Another way is just to count them. Just count them. So we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26. Okay, I get 26. Let me shrink this down again for a second. And yes, there's your choices there. So all these work. Okay, you don't need to complicate this. This is a straight up just mapping the shaded area back and forth. By the way, a lot of kids get bent out of shape. Again, you've had shading questions dealing with fractions from grade 3, grade 4, grade 5, grade 6, grade 7. Again, you're going to keep getting them for a few years. When it says the shaded region, do the shaded region. Don't do the other part. Even if it's easier to do the other part, do your subtraction from a whole or some whole number to figure out what the shaded part's going to be. Okay, when it's asking the shaded part, that's the grayed out part here. Don't do the white part. Okay? Okay, 18. Okay, Mario walks his dog every 8 days in the park, while Todd walks his dog once every 14 days. Okay, this more or less comes up every test, this kind of a problem. Both Mario and Todd walk their dogs in the park. And how many more days will both boys walk their dogs in the park in the same day? There's a couple ways to approach this. Maybe I should even mention them all. Yeah, let me not mention them all. So the first thing is try to even understand what they're even talking about. So wait, Mario, every 8 days, Mario walks his dog in the park. And every 14 days, Todd walks his dog in the park. So one day, because it says in how many more days, it's saying today both Mario and so they're in the park right now today. So if Mario does it every 8 and Todd does it every 14, when would they see each other again? Okay? Let me bring up my notepad here. So the way to do this is to set up multiples of the number at hand. 8, 16, 24, 32, 40, 48, and so on. Normally this is about enough for a problem like this, so let's see if it is. The other is 14, so what are the multiples of 14? Okay, it's 14, 28, 42. Okay, plus 14 is 56. So what we're trying to do is see if any number, the lowest number possible, that matches up in both of these. So right now there's no number that's the same. There's no 14 in the 8s. There's no 28 in the 8s. There's no 42 in the 8s. There's no 56 in the 8s. Similarly, there's no 16 in the 14s. There's no 24 in the 14s. There's no 32 in the 14s. So we're trying to find a multiple that's in both sets of these. The smallest one possible, though. Okay? So what we need to do is keep putting a few more of these then, because they didn't match up. Okay, so 56 plus 14 is 50, 60. What is that, 70? Am I doing this right? 50, 70, 84, 48 plus 8 is 56. Okay, so we don't need to do any more. We got a match there under 56. So in other words, even if we added another one, right, we'll get 64. By the way, there might be other matches here. In fact, there's going to be 112, I believe, is going to match again if we keep adding on these numbers. But the lowest number that's common between the both of them is going to be the 56. So that's one way to solve this. We could have done something with what's called a prime factorization as well. I can do that here. The prime factorization of 8, which means what are all the prime numbers that make up 8? Well, we can just start building it up. 2 times 4 is 8. Okay, if we split that down again, we get 2 times 2 times 2. Okay, so that's the end of 8. We can also do it for 14. And we basically get 2 times 7, and it's done as well. So now what we have is a bunch of numbers. If we lay out the last line of each, we get 2 times 2 times 2 times, and I'm going to put this in parentheses in a moment, times 2 times 7. And what we're going to do is we're going to remove this one, because both lines have 2's in them. So what we need to do is take only the set from the number that has the most 2's in it. Alright? We can say this is 2 to the 3rd if we want, or we can just keep it that way, times 7. And in the event we get 8 times 7 equals 56. So that's another way to solve this problem as well. In this particular problem, there was also another way to do this, which is 8 times 14 times 8. And that's 80 plus 32, so that gives you 112. But that number's too high. So, and there's no guarantees that you can use this number and do something with it. But often on a test like this, if you divide by 2, you would have gotten the 56. That doesn't guarantee it's the answer, though, because because maybe it should have been 112 divided by 3. Okay? Or something like that. And by the way, 112 is not evenly divisible by 3. So that's one way to figure out that okay, 56 was the example. Another way to do this is by brute force. You could see that in 2 days they wouldn't meet. That's just too tiny. And 22 days, which would mean if they're meeting today, if it was on 22 days, well, Mario was going to be there in 8 days or 16 days, so that doesn't work. And Todd was going to be in there in 14 days or 28 days, so that doesn't work. So you can rule this out by brute force. And if you went with 56, and you see that if Mario did that in 7 weeks, that would be 56 days. And if Todd did that in 4 weeks, all right, that would also be 56 days. And you could even test again with 112 and find that would work. But they're asking in how many more days. So it's going to be the first time. They're not going to ask the zillionth time they do it. They mean in how many days will it be very next time that they meet on the same day. Okay? So that's 18. Okay, let me just make sure I'm still live here. Okay, I'm good there. Am I good on my phone? Yes, I am. Okay. Okay, Randy spins the arrow on a spinner with 5 equal sections labeled A, B, C, D, and E. Then he rolls a 6-sided dice, 6-sided cube with the numbers 1 through 6. What is the probability that it will stop here and here? So the probability that it's going to get any one letter on the spinner is 1 out of the number of choices. So he's got 1, 2, 3, 4, 5 choices. So the probability of any one number is 1/6. And the probability that he lands on the 6-sided dice, 1/5, I should be saying. And the probability that he lands on any one number on the dice is 1/6. And if we just multiply them out, we get 1/30. So it's similar to the example earlier. What's the probability of the one? And if it's an and means multiplication in this case with the probability examples, it's going to be times the probability of the other. Okay, so normally this problem's harder than this, where it might say what's the probability it lands on A, B, C, or 2, 4, and 6, or something like that. Okay, so that makes it harder. But this one straight up, they're just trying to say, do you even understand what the fundamental concepts here? We're not going to trick you. We're not going to make it more involved. What's the issue with the probabilities here? So he's doing the both of these at the same time, so we're multiplying them. It's 1 out of A is 1 out of 5. 4 is 1 out of 6. So it's just that. We don't need to involve the number 4 or anything like that. We're just multiplying 1/5 times 1/6. Okay. What is the value of n in the equation below? So they often do this. We had an example earlier that involved the algebra. So 2n plus 1 equals 21. This one's probably even simpler than the other one was. They'll often make this, and they'll ask this multiple times. Just try to bop you around and make sure. So again, we're going to combine like terms, and then we're going to try to get the symbol by itself. So right now we have like terms. We have 2n. There's no other n term, and we have constants 1 and 21. So what we want to do is combine the 1 and the 21. So we're going to get rid of the 1 from both sides. So we have 2n equals 20. And now we only have n terms and constant terms. So what we're going to do is get n by itself. We're going to divide that by 2. We're going to divide that by 2. So we get n equals 10. Okay? Which would be 8. Okay, Rudy. Give me 1 second. I have the... Okay, based on Rudy's baseball stats, the probability that he will pitch a curveball is 1 out of 4, 1/4. If Rudy throws 20 pitches, how many pitches most likely will be curveballs? Okay? So they did some experimental stats, and they figured out it seems that 1 out of 4 times he threw a curveball. So if he throws 20 more pitches, how many times will he most likely do a curveball? So we can set this as a ratio, similar that we did before. 1 out of 4. I think it was problem number 1 even. Is how many out of 20? If we do the cross product, we get 20 equals 4x. And we have an algebra problem, so if we divide by 4 on both sides, we get 5 equals 4. 5 equals x. We could have also just done this straight up and said if it's 1/4, it's 1/4 of 20. And of is the same as multiplication. So 20 is the same as 20 over 1, so we get 20 over 4. If we do the multiplication out, and that's equal to 5. All right? That one wasn't so bad. Okay, so again, we have a problem involving a table. So I am not going to look at the words of the question yet. Jesse Spinner experiment. So this is a different kind of a table. We have an input and an output and a frequency. So he has a spinner. I guess it had at least 4 colors. Maybe it had more, but at least it did ones he checked. This one's just a no-brainer. So it seems like it landed on it. He'd actually spun it and it landed on orange 12 times. Just to kind of test myself. It landed on orange and red 12 plus 8 times, not 20 times. There's not really much more going on here. So I don't know how much more to play around with it. So let's go back to the question now that we have an understanding of the table. And again, I do this because sometimes the words can be distracting. So if I read the words first, I'm already predetermined to be swayed in a certain way by the words. And they might even, it's not that they convince me otherwise, but I'm thinking something else. So I'd rather look at the table in and of itself, by itself, even with incomplete information about the table. So I build up an understanding by myself alone. without being distracted by the words. Okay? So Jesse performs an experiment by spinning the arrow on a spinner. The spinner has 4 equal sections, so that's the only colors. I said before there may have been more. Okay, now they're telling us it's not. The result of his experiment is shown below. So he actually does this, and he does it. So now we have experimental probabilities, which is different than theoretical probabilities. Again, remember the theoretical probability of landing on one color, as long as the spinner's fair, it's not loaded in some way, is 1 out of 4. In other words, if I spun it 100 times, I would expect it to land 1/4 of the time on the blue, or 25 times. Okay? So the results of experiments are shown below. Based on the data in the table, what is the experimental probability that the arrow will land on red? So this is not theoretical anymore. The theoretical probability that the arrow will land on red is 1/4. That's D. That's not what they're asking us here. So what we need to do is figure out what happened. So we need to add up the numbers. So we're going to have 11 plus 11 plus 12 plus 8 equals, so that's 20, 30, 42. We got 42. He did it 42 times. So the number of times it went on red was 8 out of 42. No brainer. No brainer. So that should be B. What question number are we at here? 22. Right? And it's not going to be C because C does only includes the blue, green, and the orange. So it's not red versus the other ones, although it is to a certain extent. It's red including in all the choices. Okay, a scientist discovers a bone that is 7 times 10 to the 7 years old. What is this number in standard form? Okay, so I gave an example, a few examples of this in the other reviews I did the other day. So 10, again, this caret, 10 to the 0 is 1. So 10 to the 1 is 10. 10 squared equals 100. So if you notice, the exponent is the number of zeros that you add after the 1. So 10 to the 5th means putting 1 in 1, 2, 3, 4, 5 zeros. Multiply it out. Stop the video, multiply it out, and see that. So 10 to the 7th, I believe that's what it was. Give me 1 second. I don't have it on my screen. It's 10 to the 7th equals 1, not 10, 1, plus 1, 2, 3, 4, 5, 6, 7. So they have zeros in theirs. And since it's 7 times that, we're going to get that times 7, and that's going to be equal to 70 million. Okay, which is C. Okay, if you want, you can actually multiply all the things out, but if you just remember that rule, or that robotics procedure of it, it starts making sense. And again, this is just a basic question. They could have made it a lot harder. By the way, this is not a Common Core test. The Common Core test does make it harder. First of all, the questions are a little more cryptically worded, and the answers are a little more involved as well. Okay, so we're just going and trying to just cover the basic grade 7 stuff, and then we'll try to build on this with other examples as I do other YouTubes and so on. Okay, 24. What is the greatest common factor of 64 and 84? Well, that begs the question, what is their factors in the first place? So there's a couple ways to get a factors of a number. These numbers are not too bad, so we have 1 and 64. Wait, give me a second. And 84 is the other one, okay. That gives us 2 and 32. I might make an error doing this. 3, nope, 3 doesn't work. 4 and 16. Okay, 5, no. 6, no. 7, no. 8 and 8. So since they match, we met the midpoint, and that's it. So there should be no others. The other number, where was the other number again? Is 84. So in the earlier example, we would try to get the least common multiple. This is not the same as that. This is the greatest common factor. Okay, they look like they're somehow similar, but they're different problems. So 84 gives us 1 and 84. 2 and 42. Okay, 3. Does 3 go into it? Yes. 3 and what does that give? 26, I believe. I'll check that in a second. 60. Yeah, it looks like 26. And by the way, the reason I know it was 3 is when you add up the digits in the number. Let me go under here for a second. 8 plus 4 equals 12. And 1 plus 2 equals 3. So it turns out if the sum of the digits of a number or the repeated sum of the digits of a number equal 3, then the number is divisible by 3. So we can take something like 27, and we get 2 plus 7 equals 9. 9 is divisible by 3, so it is as well. So let's go back up to factoring 84. And by the way, 26 times 3 goes 3 times 20 is 60. And no, this is 28. So I did have an error. 60 plus 24. 3 times 8 is 24. Gives us 84. Okay, 4. Does 4 work? Yeah, 4 gives us 21. 5. 6. 6 works as well, yes. 6. And that gives 14, I believe. Yeah, 60 plus 24 is 84, yes. 7. Okay, 8 can't work. 9. 10. 11. 12. Does 12 work? No, 12 is no good. 13, 14. So we're done. So which factor here is in both numbers? Not just that, but which is the largest one of them? So what do we have? Is it 4? Yeah, it looks to be like 4. 8, 16, 32. Right. So the number that the largest factor of both of them is this 4. That's what I'm trying to look for. There's no 64 in the 84. There's no 32. There's no 16. There's no 8. And then going backwards, there's no 6 in the 64. There's no 14 in the 64. There's no 21 and whatever. So the greatest common factor of the both of them is 4. Okay, 25. Oh, 25 is a doozy. Wait, I think, is this the last question of the test? No, it's not. So if k is equal to the square root of 31 and m is equal to the square root of 26, which graph most closely represents the locations of k and m on the number line? So first of all, we need to try to get kind of a perspective on this. So the square root of 100 is 10. So the square root of 105 is a little more than 10. And then we have 11. 11 times 11 is 121. So the square root of 121 is 11. The square root of 105 is a little less than 11. And like we just said, it's a little more than 10. Okay? So what we need to do is use that same kind of logic here and try to make sense of these. So I'm going to use this notation here where I do what? What am I going to do here? If I do this, that means square root. So the square root of 25 is 5. Okay, and the square root of 36 is 6. And let's just get some other ones that are right around that. In other words, we're gonna try to get square roots that are around the two numbers in the example. So the square root of 49 is 7, and let's use the one here, which is going to be the square root of 16, equals 4. So The numbers we're looking for is 26, which is a little higher than that one, and 31, which is a little higher than this one. So that means the answer's got to be between 5 and 6. It's got to be between 5 and 6. It has to be, it looks like A. Okay, it may not be the best answer yet. It can't be B, because B is already less than 5. So that means it's 4 point something. But M is square root of 26. So the square root of 26 is somewhere inside of here, between the 5 and the 6. Okay? So it can't be B. And for K, it's the square root of 31. The square root of 31 also has to be inside of here, if we use what we just built up. Because 6 squared is 36. So the square root of 36 is greater than the square root of 25. And the square root of 36 is also greater than the square root of 31 and 26. And the square root of 25 is less than the square root of 26 and 31. Right? Because this is going to end up being 5 point something. 5 point x. And x is probably 1 or 2 or something. And this is equal to also 5 point something. That's called 5 point y. Well, y might be slightly higher. So it might be 3 or 4 in this case. Okay? So that means they're all within the 5 range. So M is too low and B, and K is too high. So if we go to C, M is too low and K seems to match the number I gave, like 5.5 or something. So that's K seems okay, but M doesn't. And then in D, M seems okay. It's a little over 5, but K is too far away. So the one that matches is that M is less than K, right? So let's be clear that this was M and this was K. So K is larger than M because it's the square root of 31. The square root of a larger number is a larger answer, and the square of a lower number like M is a lower answer. So first of all, K is greater than M in A. And we said that M is probably about 5.1 or 5.2, and K is about 5.4 or 5.5 or something like that. And that's about what it is. Okay, remember these are not to scale. They're not drawing these to scale. So A is your best answer here. And by the way, it said most closely. So there we go. All right? And then finally, I believe, nope, we still have a few more questions. Jeffrey wants to measure the mass of his fish tank. So here we have another one of these unit kind of questions. We're just trying to figure out, do you know what all the different units are? Which tool is best for him to use? So he wants to measure the mass of his fishing tank. Could he use a ruler? No, that measures the length of it. Could he use a scale? Yeah, that deals with the weight of it based on Earth's gravity. So that's dealing with the mass. Okay, so it looks like B. Could he use a tape measure? The mass of his fishing tank. No, we're not trying to figure out the X, Y, and Z coordinates of it. We're not trying to find out what it looks like as a cube or a rectangle, assuming it's that even that shape. It could be different shapes. So that's involving length again. And a measuring cup deals with capacity. But we're not trying to figure out how much water it would take to fill the tank. We're just trying to find out what's the mass, how heavy is the tank, basically. So 26 would be B. Okay. 27. Oh, this test just goes on. Which number is the square root of 196? So what times what gives 196? So you may happen to know this in your head. I would suggest that you actually start doing and try to figure out some of those. Go beyond 12 by 12. A lot of these come up in standard tests, and if you have that at the ready, especially on a standard test that's timed. Again, this state test is no longer timed. It used to be, but you're going to be taking many other tests in your life that are timed. So unless you have special accommodations like an IEP, and even with an IEP, you should make your goal to try to get through questions like this. These kind of questions should not be the stumbling blocks for you on a test like this. In any event, if you run through them, 12 times 12 is 144. It's not it. And again, you can write it out in long multiplication if you want. You know, the standard one of these thingies and write out all the answers underneath here. Gobbledygook, that's the numbers. You add them up, and then you finally get your total here. Right? These are your subtotals or your subcomputations. Okay. 14 times 14. If you do that out, that turns out to be the 196. If you do the others, they're not. By the way, there's some clues here, which is that you could also use. In this case, it's not going to help you 100%, but there's a truism that if you take the ones column of any number that you're multiplying against the ones column of another number, that you will know the ones column of the total. So if, for instance, I have 1, 2 times 3, 4, okay, and I want to multiply that out, because the 2 times the 4 is 8, I know that the final answer, whatever this happens to be, if I multiply them, it's going to end in an 8. Let's give another example. If I have 2, 3 times 3, 4, I know whatever is here is going to end in a 2 because 4 times 3 is 12. So if I take the ones column times the other ones column, the ones column of that answer is always the answer here. So if you go back to the original problem, if I have 12 times 12, I know it's going to end in a 4. If I have 14 times 14, that's 4 times 4, that gets 16. So I know it's going to end in a 6. So that means A is no good, B might be good. 6 times 6 is 36, so C might be good. And 8 times 8 is 64, so D is no good. So I can rule out A and D by this. So this is maybe a weak double check, but there's other examples where this is actually a good double check. Okay, so there's multiple ways to do some of this. And if nothing else, do the multiplication twice. And by the way, I like to suggest to students that if you're doing a computation like 23 times 34, however you do it backwards too. Do 34 times 23 as well. Okay, and see if it's equal to the answer you got. If not, one or both are wrong. Okay, and doing this, even this doesn't guarantee that your answer is right. But still an alternate way to double check some of this. And as much as possible, you want totally alternate ways to do some of these things. Okay, 27. It's still not the last question. The square root of a number is 8. No, the square root of a number is between 8 and 9. Which of these could be that number? So this is kind of the same question as this, but with a different spin on it. So they're getting deeper. When we started the test, it wasn't too bad. So now we're into some deep poop right now. Okay, because the questions are starting to get a little deeper, a little trickier. So the square root of a number is between 8 and 9. Which of these could be that number? So the resolution is just take those two numbers and square them. The two numbers being the 8 and the 9. Let me bring this up. Let me bring up my notepad again. So 8 squared is 8 times 8, or 64. And 9 squared is 9 times 9, or 81. So it says the square root of a number is between 8 and 9. So it's not including 8 and 9. So the square root, if the square root of 64, because if we go backwards, the square root of 64 equals 8. And the square root of 91, of 81, is 9. So it says the square root of some number is between these two. So the answer is somewhere between these two. So the answer is somewhere between 8 and 9 squared. So in other words, it's somewhere between the square root of 81 and the square root of 64. So it can't be A because 17 isn't between 64 and 81. And it can't be B because 63 is not between 81 and 64. 71 is. 89 is not. So 28 is C. Okay? Okay, which list is the number below is a set of irrational numbers only? Oh, yeah. Really slapping us in the face here. So an irrational number is basically a number that can't be represented as a fraction. So what if you don't know that or remember that, or things? There's other kinds of numbers, counting numbers, and there's numbers that have repeating decimals, and some can be decimals, but some go on infinitely, and there's all these combinations of stuff. So there's something funny about these examples that can then help us rule out. At least get, so normally you start it, if you have 4 choices, you have a 25% chance of getting it right. So there's something here, if you notice, between some of these that that if we take, for instance, B and C, they both have a third, they both have this, and they both have this. Okay, so it says, which list of numbers below is a set of irrational numbers only? So if you look at this, if C was the answer, then it means B has to be the answer. So if C was all irrational numbers, because B is a subset of the list of the things in C, then B would also need to be the answer. So that means C can't be the answer. Okay? Just out of approaching this from a test-taking strategy. And if we look at the others, if we look at D and A, okay, we have 21 matching up and 5 matching up. So we run into the same problem. Because if D was the answer and it contained only irrational numbers, that means A would have to also be the answer. So from that reason, it can't be D either. So let me clear this out. So now you're left between A and B. Okay, and if you kind of look through and do an analysis again, well, the difference between A and B is that A has only these rationalized things, the square root of 5 and the square root of 21. B also has a square root thing, but it also has 2 other members. It has a regular fraction, 3/5, and another regular fraction, 1/3. So it would seem for that reason that A wins, because B has other stuff that A doesn't have. That would seem because B only has the square root things. So even if you didn't know what an irrational number was about, you would get that. Because if you try to compute the square root of 5, you're going to get a very long number that probably goes to infinity. Same with 21. All right? So you should first of all know what the different number sets are about and what they are, and then you can use these test-taking strategies to rule out stuff when you don't know the answer. Okay? And even if you couldn't get this down all the way, go from a random 25% each down to 50, down to 33.3%, whatever. That's all improving your option to getting the answer right. Okay. 30. Finally, the last question. Brandon wants to conduct a survey as to whether mushrooms should be added to the pizza sold in the cafeteria. School cafeteria. What sampling method would offer Brandon the best results? So I'm going to read the first sentence again. Brandon wants to conduct a survey as to whether mushrooms should be added to the pizza sold in the school cafeteria. So it seems to me he should be asking as many people as possible in the cafeteria. So let's see if any of those match up here. And again, it's asking which is the best results. So that choice I just said may not be in the list of the answers. So if it's not, we have to hedge our bets and see which one gives us the most. So what we're trying to get is the best population possible out of the set of people involved, not just random and not at weird places. Okay. So A, interview every vegetarian student. Okay, that could work, but what about the non-vegetarian students? Because he wants to conduct a survey to see if they should be added. It may turn out there's no vegetarian students, and so on. Interview every student at a pizza parlor. Yes and no, because they could be students from another school. He also has to ask them first if they're a student or not. So if he's in the school, he may know they're a student, or there's pretty much a better guarantee that it's the case. So A seems too small a sample. Again, we don't know what other choices there, so they might be the best answer. But right now, they seem to both be weak to me. A is too small a subset of the group of people eating different kinds of food. B just seems to be like, it could work, but it's somewhere else. It's too far away from the school, and so on and so on. C, interview every student who brings lunch from home. I guess that could work if it was the best, and see who was liking mushrooms. But that's not really the target audience. The audience is not just students who brought lunch from home. It's everybody. Okay, and D, interview every student who eats lunch in the cafeteria. Yes! He's trying to find out whether the cafeteria should serve mushroom pizza, right? So D is the best answer there. Okay, and we're done. So let me bring back me. All right, so we went through a book 1 from a previous New York grade 7 state test. It was not a Common Core one. Again, the question styles are different, but I like to work with fundamentals first to make sure everybody's on an equal playing field before we add complexity into it. An issue with the Common Core test is that if you have a problem with the question, are you having a problem with the question, or are you having a problem with the fundamental math? So that can be important there. But at the end of the day, grade 7 math is still grade 7 math. I'm just approaching this from a non-rigorous perspective. Again, my name is Greg from GregsTutoringNYC at gmail.com. Hope everybody is having a good day. I'm going to have to get back to doing my taxes now. Again, I do a lot of tutoring for specialized tests and New York State tests and other things like that. Feel free to email me with other suggestions for YouTubes. I'm doing this little series right now. There's some other ones based on grade 7 and grade math as well, based on input from students and from people on the internet and other places. And of course, if you want me to tutor you, I'm there. We can work out a date. And I switched gears after the New York State test in a couple of weeks. I'm going to flip into more or less just specialized high school testing. There's the Hunter test. There's the New York 8 specialized New York City high school test. There's other screen schools. There's also other private schools like the ISEE and the SSAT and other things like that that I can help students with of all ages. I like to focus on elementary school kids and middle school kids, but the specialized high school tests normally involve more math and English and stuff like that. Writing is a serious problem that a lot of kids have. Even the brightest child needs super duper work on their writing skills and so on. And I can help like that. Peace out, everybody, and have a great day.